Hello, and welcome to The Space Above Us. Episode 14, Project Gemini Flight 2, Gemini IV. One big step. Last time, we kicked off America's second manned spaceflight program, Project Gemini, with the flight of Gus Grissom and John Young aboard Gemini IV. Though only orbiting the Earth 3 times, the short flight put the Gemini spacecraft through its paces and proved that a number of major systems were functioning as intended. With the spacecraft shakeout flight under NASA's belt, it was time to start tackling the main goals of Project Gemini. Following Gemini 3 was, of course, Gemini 4. But here's where the audio format of the podcast fails me just a little. Were that previous sentence in text, it would have been obvious that Gemini 4 was the first NASA flight to begin using Roman numerals to denote the mission, rather than traditional Arabic numbers. I'm not entirely sure why NASA made the switch to Roman numerals, but given the timing, I suspect it may have been in response to Gus Grissom's tongue-in-cheek choice of call sign for the Gemini 3 spacecraft, Molly Brown. Managers were not impressed by Grissom's choice since they felt it lacked the dignity such an important endeavor deserved. Gemini 3 remained Molly Brown, but all future Gemini missions were referred to simply by their mission number. Roman numerals do seem to add a bit of gravitas to any situation, so I suspect that this is why they were included at this point. Another fun fact about Gemini 4 that doesn't really fit in anywhere else in the episode is that there was no official mission patch at the time of flight. Perhaps feeling a bit left out when seeing all the cool patches made for later Gemini missions, a patch was made after the fact, but did not fly in space with the crew. However, they did become the first astronauts to wear the now traditional American flag patch on their spacesuits. Before we can really start talking about Gemini 4, we need to take another quick jaunt across the ocean and check in with our friends at the Soviet Union. The Soviet space program had been pretty busy as Gemini was just getting off the ground. While they were hard at work on their next-generation Soyuz spacecraft, there was massive political pressure to fly multiple cosmonauts aboard one spacecraft as soon as possible in order to beat the Americans to the punch. This may seem like a somewhat odd order, but it makes perfect sense when viewing the Soviet space program through the proper lens. The thing you have to understand about the Soviet space program is that it was all about image, first and foremost. I'm not trying to discount their technological accomplishments, but with the political climate in Russia in the 1960s, image and perception definitely came first. Let's compare the flights of Yuri Gagarin and America's first orbital astronaut, John Glenn. Both were pilots, but Gagarin was essentially cargo just along for the ride. The Soviets wanted the PR victory of having flown a human in space first, without all the uncertainty that comes from giving the human, actual agency over the flight. Meanwhile, John Glenn was an expert in his spacecraft and skillfully piloted it throughout the flight. Voskhod, the immediate successor to Vostok, was a similar situation. The Soviet goal was not to figure out the best way to fly multiple cosmonauts aboard the same flight in order to work on long-term projects in space. Soyuz would accomplish that in a few years. Their goal was to stuff 3 guys into a modified Vostok capsule and get the thing into orbit before the Americans could get their 2-man capsule off the ground, so they could gloat about how much progress they were making. And they did it. On October 12, 1964, just a few months before the flight of Gemini 3, 3 cosmonauts orbited the Earth for just over a day before landing safely. The fact that in order to fit 3 men they had to recklessly fly them without pressure suits didn't seem to bother the Soviets. This is the kind of competition that NASA was in, so it shouldn't be all that surprising that just as Project Gemini was about to begin, the Russians cobbled together a way to beat the Americans to another one of their major goals, extravehicular activity. Just 5 days before the flight of Gemini 3, the second and final Voskhod spacecraft flew with 2 men and some specialized equipment aboard. If you happened to be outside the Voskhod capsule 90 minutes later, you would have seen something odd. A structure attached to the side of the descent module started to inflate. Shortly afterwards, a hatch at the end of the inflatable structure opened, and a helmeted man's head popped out. The man was Alexei Leonov, and he was about to perform the world's first spacewalk. As Soviets watched on live television, Leonov drifted away from his spacecraft, attached only by a communications umbilical. Leonov took some photos, enjoyed the view, and returned to the inflatable airlock 12 minutes later. He found it difficult to re-enter the vehicle, with his spacesuit now stiff from the pressure differential and with several cameras to juggle. He eventually did manage to wriggle his way back into the safety of the spacecraft, and Russia checked off another box on its list of firsts. The flight of Voskhod 2 had a somewhat dramatic conclusion that ended with an off-target landing and a multi-day recovery effort in the Russian woods, but both men were eventually recovered safely. The flight of Voskhod 2 provided strong incentive to NASA to respond and perform a spacewalk of their own, but they were already hard at work on the problem anyway. The idea of performing even a stand-up EVA, where the astronaut would stand on his seat and poke his head and shoulders through the door, had been around for several years already. The astronauts were all for it, and pushed hard to complete a stand-up EVA or full spacewalk as soon as possible. In fact, if it wasn't for the strong campaigning for early EVA from the Gemini IV crew, it likely wouldn't have happened until much later in the program. What makes EVA so tricky? Let's learn about some of the tech required. First, you're going to need a spacesuit. Now, I know what you're thinking. I thought they already had a spacesuit. What's that silvery suit with the helmet? Well, first of all, the suits are white now. My bad, I forgot to mention that last time. Second, those suits were considered a backup in case the spacecraft environmental system failed. With an EVA, there would be nothing but a few layers of specialized fabric and glass between the astronaut and the inky blackness of space. The suit worn by a spacewalker had to be perfect, guaranteed, or there was no way he was going to be able to leave the capsule. By the way, Worcester, Massachusetts makes another brief cameo at this point in our story. The suits for Project Gemini, along with the Space Shuttle and many other high-altitude flights, were made by the David Clark Company in Worcester, Mass., just 2 miles down the road from my and Robert Goddard's alma mater, Clark University. In addition to the suit, you're also going to need a portable environmental system that the astronaut can bring with him, a tool for him to get around, and a tether to keep him from floating off into space. The tool for him to get around, in this case, took the form of a so-called zip gun, a small handheld device that expelled gas through various nozzles to allow the astronaut to sort of putt-putt around once he was outside of the vehicle. That's the technical term, by the way, putt-putt. No, it isn't. The crew of Gemini 4 were eager to show the Russians that they too could walk in space, and luck was on their side. Despite the considerable complexities involved, all of the required equipment for performing a spacewalk passed qualification and was ready to use shortly before their flight. There was really no reason not to do it, so do it they would. I mentioned the crew of Gemini 4 a few times there, so I suppose it's time to properly introduce them. Flying in the left seat would be command pilot James Jim McDivitt. Alongside him, serving as pilot, was Edward Ed White. Both these guys were from Astronaut Group 2, also known as the New Nine. They were both spaceflight newbies, so it's time for everybody's favorite, astronaut biographies. Jim McDivitt was born on June 10, 1929, in Chicago, Illinois. McDivitt joined the Air Force in 1951 and served in the Korean War, flying 145 combat missions in F-80 Shooting Stars and F-86 Sabres. Those are jets with totally rad names. Following the war, he reported to Edwards Air Force Base as a test pilot. Like the rest of his New Nine compatriots, NASA selected him as an astronaut in September 1962. This was his first of 2 flights in space. Ed White was born on November 14, 1930, in San Antonio, Texas. Another Air Force pilot, White attended West Point and then flew in a fighter squadron in West Germany, flying the F-86 Sabre and the even cooler-sounding F-100 Super Sabre. After his stint in West Germany defending NATO, he went back to school and received a master's degree in aerospace engineering. He went to test pilot school at Edwards and eventually served at the Wright-Patterson Air Force Base in Dayton, Ohio, where he was a test pilot for research and weapons development. This was his first and only spaceflight. White was to fly again on Apollo 1, but the crew was killed in a training accident. There's obviously a lot to say about that, but we'll be getting to Apollo 1 soon enough. As I mentioned, America's first extravehicular activity was actually a late addition to the Gemini 4 flight plan. While it became a main goal and a highlight of the flight, the original goals were to extend our maximum mission duration in space up to 4 days, as well as attempt station keeping with the upper stage of the Titan II rocket. Station keeping just means that McDivitt would use the Ohms thrusters to attempt to stay close to the upper stage. This may sound straightforward, but as our crew is about to learn, things behave differently in orbit. In addition, Gemini IV also carried a number of scientific experiments for the astronauts to perform during their lengthy journey. June 3rd, 1965 was launch day for Gemini IV, just 72 days after Gemini III. To give you an idea of just how new the space age still was, this was the first launch that Europeans would be able to watch live, thanks to a new communications satellite. At 10:16 a.m., Americans and Europeans alike watched as the Titan II smoothly carved a path through the sky. The booster slowly pressed its 2 occupants into their ejector seats with the ever-mounting forces provided by its LR-87 engines. Before long, the booster's job was complete and the spacecraft was on its own, in an elliptical orbit with a high point of 282 kilometers and a low point of only 163 kilometers. The Titan II's role in the mission wasn't quite complete yet. After Gemini IV separated from the upper stage and used its thrusters to move away from it, the stage trailed behind it in orbit. McDivitt's goal now was to pilot the spacecraft closer to the spent booster stage and attempt to stay close to it as they revolved around the Earth. However, problems emerged almost immediately. Later Gemini capsules would be equipped with advanced radar instrumentation in order to accurately gauge the distance to other spacecraft. Gemini IV did not have this luxury and had to rely on the eyes of the pilots. The command pilot and pilot disagreed on the range by a significant amount. McDivitt guessed 120 meters, White guessed 75. They couldn't agree on how far away the booster is, but it was clear that it was moving further away. McDivitt used the attitude control thrusters to point the spacecraft at the booster, and then fired the OMS thrusters directly towards it. As anyone who has played Kerbal Space Program knows, and as our fearless crew is about to discover, this doesn't exactly work how you would expect. Space is weird. Orbit is weird. Things don't always make intuitive sense. In this case, despite firing the thrusters while facing directly towards the booster, it actually appeared to be moving away from them. Flummoxed, McDivitt tried several more times, only to discover that the booster was moving further and further away. So, what is going on here? I've had some difficulty tracking down the precise maneuvers performed by Gemini IV, but I can describe a similar scenario that will help give you an idea of what happened. Let's imagine that you and I are in identical circular orbits, but you're a few hundred feet ahead of me. If you were to turn towards me and fire your thrusters, what would happen? If you were Jim McDivitt or any other normal person, you'd expect to start moving towards me. Instead, what would happen is that from your point of view, I would start moving upwards and away from you. Why? Because to point towards me, you had to face away from the direction of travel. So when you fired your thrusters, you slowed your orbit down a little bit, lowering the lowest point on the other side of the world. No big deal, except now your orbit is shorter, so it doesn't take as long to go around, which makes you faster than me. It also makes your orbit lower, so you start sinking relative to me. This is all super weird and confusing, so if that doesn't make a ton of sense, I don't blame you. I'll get more into the intricacies of orbital rendezvous a few episodes down the line, but for now, our takeaway will be that McDivitt and White were thoroughly vexed and wasted a fair amount of fuel trying to chase down their spent booster rocket. Next, let's talk about the highlight of Gemini IV, the extravehicular activity. The crew took a little time to relax after the stressful attempts at station keeping, so the spacewalk was delayed for one full trip around the world. With spacesuits fully secured, the crew began to depressurize the cabin, already an American first. Once the cabin was fully purged of air, the first problem emerged. The door wouldn't open. I always enjoy stories like this one because I like to pause and take a moment to envision the whole scene. You've got 2 highly trained astronauts wearing state-of-the-art spacesuits in their state-of-the-art spacecraft, whizzing around the world being tracked by state-of-the-art equipment and managed by some of the smartest people on Earth. So how do you fix the door? Just yank on the handle until it pops open. Let's see a robot do that. The door eventually opened, and Ed White's head soon followed it, surveying the scene. With his trusty zip gun in hand, he was soon drifting up and away through the door, leaving the spacecraft behind. White had a pretty enviable task. Typically on a spacewalk, everything is scheduled down to the second, and there's no time to spare on taking in the view. With White's EVA, the only official tasks were to try out the zip gun, soak in the experience, get back in the capsule, and then report back on how it felt. White drifted about 15 feet away from the spacecraft, trusting his tether to keep him secured. He could see the Earth slowly slipping by beneath him, the thrusters on his spacecraft occasionally firing to maintain attitude, and the whole universe above him. It really must have been quite a sight. This flight happened to be the first NASA mission that made use of VOX, or voice-activated microphones. Up until this point, whenever astronauts wanted to speak to mission control, they had to press a button. Gamers everywhere will be familiar with the hassle of having to press to talk. By accident, the crew was in the wrong voice mode, and while they could talk to each other, mission control was getting no update and couldn't break in. After nearly 16 minutes, McDivitt finally called down to the ground to ask if they wanted anything. The response? Tell him to get back in. Ed White said it was the saddest moment of his life. He begrudgingly returned to the spacecraft, they closed the door, with a similar amount of banging on the handle to get it to close, and repressurized the vehicle. The first American spacewalk was complete. I'm sure all the mission controllers in Houston breathed a sigh of relief when the first EVA was complete. But wait, Houston? That's right! This was the first mission to be controlled from the new Manned Spaceflight Center in Houston, Texas. I was going to talk a bit about how mission control in Houston worked, especially with a 4-day mission, but this episode is running a little long, so I'd like to skip it for now and save it for the ridiculously long flight of Gemini 7. So that's it. Okay, I mean, there were another 3 days of the mission and a bunch of science experiments to complete, but that sums up most of the fun stuff. When the time came to return home, the crew struggled with the onboard computer until it finally just broke completely, so they had to return on a ballistic profile just like in the Mercury days. The computer was a concern, but after 4 days and 2 hours in space, the Gemini IV crew splashed down safe and sound, their place in history firmly established. They had taken the first steps towards perfecting the vital art and science of spacewalking, learned valuable lessons about the weirdness of orbital rendezvous, and their flight was longer than all previous American flights combined. That record wouldn't stand for long though, since next time, Gemini V will up the ante and use its slick new fuel cells to stay in space longer than any human had before up to that point. The crew would also use the lessons learned from Gemini IV to show how rendezvous is really done. So, with so much to do, why did Gordon Cooper lament that he didn't bring along a book? Find out in 2 weeks. Ad Astra. Catch you on the next pass.